Hello, Vishal. There, Vishal or Neha.
Hello, sir.
Hey, so is student going to join or how it is?
Just sir, Vishal sir is not there. I'm on Rag,
Hey, Anurag. Yeah.
joining from Grid. Yes, sir. Today we send
Um.
a reminder to a student.
Sorry.
Yeah, we send a reminder to a student. So
All right. Let's wait
joining
for
the
a few
class.
more minutes. Yeah.
Yes, sir. Yes.
All right. So where we were, sorry, we were on the discovery part, like. Just give me a second. Let me open the lab and. Right. So to give you that the broad picture, what we are going to discuss and how the syllabus looks like, okay? Because we have discussed the basic ACI, and let's discuss the module wise where we are and what we are going to cover so far, okay? So if you see that here, these are the total. We have around 15 modules in ACI, okay? So module number 1 is overview, which is already done. Module number 2 is already done, which is ACI hardware. If there is any doubts, please let me know that. Module 3 uh, is yet to start. So from here, module 3, all the way it is pending. Okay, so these two modules are done basic of ACI. So today what I'm going to do here is, today I'm going to do the hardware installation. Okay, this is the something in the module 2 which is pending. So we have discussed last week how the hardware installation works. Okay, when you purchase any hardware, when you purchase any devices, how these setups works. So suppose when you purchase your box, your ACI leaf and spine, you purchase a Cisco APIC, that's a prerequisite for the all the ACI setup. You need to have a spine, you need to have a APIC, you need to have the leaf switches. Without any of this component missing, you will not be able to configure the ACI. Okay, minimum to start with the ACI, you need a minimum one APIC node. Okay, one APIC node is a minimum requirement. It's not like you need a minimum 3 or 7 or something like that. No, to start with, to start the discovery process, you need just minimum one APIC. Okay. So what I'm going to do here is I'm going to have a 3 APIC node, and I have a leaf spine switch here. Spine 10, for example, 201. Okay. Spine, this is the device node ID 201, 202. You can give any number. It must be 3-digit number. The device ID must be minimum 3-digit. You cannot have a less than 3-digit. Maximum you can go 6 foot. Excuse me. 0012 something, 6500 or 1000 something. Okay, it's up to you how you want to define that. That's a minimum node numbering. Node numbering for ACI, leaf, and spine. Okay. Now, as we discussed, we have a dedicated interfaces, and these interfaces are special interfaces, the fiber interfaces. You cannot have RJ45, you cannot have any 10 gig or 25 gig interface between the leaf and spine switches. Yeah, yeah, Avinav? You are speaking, Avinav? We are unable to hear you. If you are. No, I cannot hear you. Yeah. There might be some audio issue from your side. Okay. This is a leaf switch. The leaf switch numbering, you can have anything as you wish. So I'm going to have 101 as a leaf switch ID. Okay. You can give the host name anything, whatever you want. Okay. Let's say that what type of leaf switches we have, what type of spine switches we have. Okay. If you talk about the leaf switches, we have 3-4 types of leaf switches. When I say the type of leaf switch, it doesn't mean they are really, having some magical feature. No. Any switches which has a server connectivity. Compute leaf. Any leaf with the server connectivity. So basically, this is a server intensive hardware. You need layer 2 or layer 3 memories on these leaf switches. Okay. Then second type of switches, this is just a condition. We do not do any special configuration to make this one thing. Like just like in a production environment, we make access switches, distribution switches, and core switches. Though core switch can be distribution switch. Distribution switches can act as a access switches, right? But this is just a name of the role because of the configuration of the switches. Okay, we have a service switches. What they serve? Layer 4, layer 7. Firewall, load balancer. These are the switches we call as a service leaf switch. Third type of is border leaf switches. External or with the layer 3 routing towards, or you say that any leaf switch which has a layer 3 routing. For example, in the leaf switches, you connect to your WAN router. In leaf switches, you connect to your firewall. In leaf switch, you are trying to run the dynamic routing or static routing. That leaf switches usually we dedicate those 1 or 2 leaf switches for the just routing functionality. Treat them as a core kind of device, yes, because those switches are single point of landing zone for you for the external traffic or for the internal traffic also. Okay, so those kind of switches which has this functionality, when we run the dynamic routing with the external device, not with the leaf and spine, with the external device, we call those switches as a border leaf switches. Okay, there are a few more switches, but it really doesn't matter. We have a tier 2 switches. Okay, I will talk this one what is the tier 2 switches are. Okay, there is a no spine the role differences. There is no any super spine or something kind of stuff. There is no, just leaf and spine switches. Any leaf switches, any hardware which has just compute nodes. In production also few switches we call server switches, right? We have a DMG switches where we have all the layer 4, layer 7 connectivity. We call that service switches here. We have anything like external connectivity. We in our environment, we call that legacy environment, we call that core switch or distributions, aggregation switch. We call that border leaf switches. This is the border of your internal external communication, right? Any doubt in the role of these switches? Okay, I'm taking as a no, there is no question. Now, what about these the APIC devices? Okay, so here minimum requirement for the leaf and spine connectivity is 40 gig to 400 gig. Supports is minimum 40 gig to 400 gig. Okay, based on your requirement. In your environment, if you have a server which are having a 40 gig bandwidth or 100 gig bandwidth, then go for the 100 gig or 400 gig link between the leaf and spine. Though those one SFP cost you $2,000, like 1.5 lakh. Here, if you're having a 1 gig or 10 gig connectivity in your environment, then 40 gig interface between leaf and spine should be enough. So as I said, how many interface you want to connect between leaf and spine is based on your the server farm size. Suppose your server farm having like thousands of servers, then you should be enhancing the interface number of the interface between the leaf and spine switches, because you have a 6 ports minimum reserved for the leaf and spine connectivity. Why Cisco started with the 6 port? Because in initial phase of the spine leaf switches, only maximum 6 spine were supporting. Okay, now if you see that leaf switches are coming with the spine port which has a support of 25 spine switches. But those switches are especially designed for that kind of role. Those switches can perform as a leaf and as a spine both, because they have all the interface belong to the 40 to 100 gig, right? Now, if you see the 9800 switches, currently Cisco has introduced 9400 and 9800. They do support the 400 gig interface. Okay, not the 9500 or 9300 switches. They support only 40 to 100 gig interface. On the leaves, on the spine switches, all the interfaces of the spine switch support 40 to 100 gig or 400 gig support, 400 gig interfaces. Okay, unlike the leaf switches. What is the difference between leaf and spine hardware? The minimum is a 40 to 400 gig support. All the port will be 40 gig to 400 gig. Max to max 2 interface. It depends on the hardware, not all the hardware. Max to max 2 interface will be 10 gig for different purpose, which I will discuss that. Max. Okay. Whereas the leaf switches has a flexibility based on the server farm requirement. It can support the 100 M to 100 gig interface, or 400 gig nowadays also call that. So server farm, since these switches are required to connect the server devices and other, we need to have a special hardware to accommodate those kind of backward and the forward compatibility with the existing hardware or the new hardware of the environment. Okay. Between the leaf and just give me a second. Between the leaf and the here, this is a special connectivity. For example, here.
Hey Vijay, I have a question.
Yep.
So let's see, your spine will be the 400 gig interface and leaf will be the 100 gig interface. There will be no compatibility match on this, right?
No. I'm
So
saying
is there
that.
any way to do that?
No, just give me a second. Just give me a second. I did not say that one side will be 100 or another side will be.
No, you are not
50.
saying actually. I'm asking this question. Like, let's see, one side it's 400 and one is 100. Is it like, is there any way we can use the same 400 interface and do some config changes to match those things, or you have to
Which
mandate this?
no, so if you are configuring one side 100, okay, this side also must be 100. So this must be the same. You cannot have a one side different, one side another side interface different. I'm saying that
So
these
you can
interfaces.
you don't have any split option on this. You're saying
No.
okay.
You have to have these interfaces are reserved, okay, especially for
No,
the some
that's
hardware.
fine. What I'm saying, like, let's say in this, some of the case, we have purchased in the 400 interface, 400 gig interface in the
We do
spine
have
switches.
a split option. Yeah, we do have a split option in the hardware, but those hardwares are, I think, 9800 some line cards, not all the line cards.
Okay.
When you purchase the hardware of the 9800 or 9400, or even in case of the 9500, I'm not sure whether they support any 400 gig, but in 9800 and 9400, if I show you this Cisco, this 𝗀𝗶𝗀𝗆 works really fine. I don't get a lot of advertisement on this browser. I like the Chrome and all. For example, if I go modular switches, okay, 9400, 9800. So if you see that 400 gig even designed for 800 gig adapter. So these are bandwidth intensive hardware. So look here. So depends on these are the slot switches, right? So you have to be really order the specific devices which will support the 400 gig model. Just give me a second. These are the 9500, 90. Okay, these are the 9800, like 36400 gig. These are the port, right? So they say that 34. Okay, so if you see the 14, if you are using these switches, 14 400 gig, okay, plus 10 3400 gig ports, you can use that. But I'm not sure. I don't think we have a break option over here now, because these are the line cards. Break options were supporting, in the old hardwares, but nowadays, Cisco doesn't go that way. So I don't think there is any option called the break. It was supporting for sure in till 9300 and 9500, not in 9800, which are 400 gig interfaces. If you see for 9400, do we have that support? But I've never known, Cisco can introduce anything anytime. So never trust. We when you require when you have that kind of requirement, because interface must have that kind of the ASIC design.
No, that's fine. That's fine. Like, the interface should be the same match whenever we are going to order. But it's just for curiosity. Like, I thought, is there any option or something?
No, so
but it's
those
okay. We can
ports,
continue.
yeah, those ports must be supporting the breakout, not any random port you can connect and break out.
Toy doctor. And toy doctor any?
Visit, you can mute.
EOE or toy doctor in
Yeah, so as I said, you need to have a special interface to which support the breakout. SFP 400 gig breakout support. Because the reason I'm saying that between leaf and spine switches breakout issue, because this is the pre-configured, okay? So it says 9410 gig to 200 gig breakout, okay? This support 9400 does support breakout, okay? Let's see what else switches. 9800 scale in. No, this doesn't support. This one supports the breakout interface. So as I said, it depends on the module to module, what module you are using. But between leaf and spine switches, answer is no. You should not running the breakout. And I never seen that any solution which use the breakout, and I don't think it will support, to be honest. You can break out for the host interface, not the fabric interface, because fabric interfaces are predefined for you. Okay, if you change anything, it may create the issue, right? All right, so if you go for the APIC hardware on the leaf and spine switches, after that, you purchase the APIC hardware. APIC is you can say is a JTP server, zero trust provisioning server. If you know the SD-WAN solution, we call that 𝗵𝗀𝗀, right? That 𝗵𝗀𝗀 is an authoritative server, orchestrator, right? To authenticate everything. Your APIC devices are GTP, zero trust provisioning devices. These are the devices, whatever you changes you want to make in the leaf and spine switches, you do it from here. Okay, when you configure these APICs, you just configure the APIC cluster. Okay, cluster will be formed differently. Then you have out of band IP address, OB IP address. Each devices will have a different OB IP address. Then you have a separate CIMC IP address. Okay. Then you have a separate CIMC IP address, which is your server ILO interface. You can say that server management interface or server console interface. CIMC, you call that ILO, you call that console, anything you call it. Okay, this interface. CIMC interface is for the APIC. APIC is what? Is the APIC is the image which is installed on top of the Cisco UCS hardware. Okay, in order to access that image, you need to configure the out of band management IP address. CIMC address you need to configure in order to console these servers. Okay, so when you first time purchase your server, you need to connect the CIMC interface. Then you log into the APIC CIMC interface page and you configure the APIC setup, where if the APIC image is installed, then you configure the out-of-band management address, then you certain parameters on the APIC. Okay, these interfaces which are connecting to the leaf switches, these we call that fabric interface, fabric ports. And this minimum required is a 10 gig. It can be copper, it can be fiber. Okay, these interfaces. Now, one interface from each node will be active and second interface will be standby on each APIC. On each APIC. If you're connecting just one interface to one switch, that's well and good for you. But it's always recommended to connect the just two interfaces split into the two devices. If you're having a, like for example, 100 devices, leaf and spine switches including, you can pick any leaf switches where you want to install the Cisco APIC. You can connect any devices, and that doesn't mean if you're connecting that device to the APIC, you need to have a certain specification, certain parameters, or you cannot configure anything. No, those devices, those APICs will be connecting to any random switches, and they will act normally. Those switches you can use for anything else. It doesn't matter you're connecting APIC or not. Those are the few normal ports. They do not require any special port, unlike we have a leaf and a spine, where we have a special reserve port on the leaf switches, which we call the fabric ports, only need to be connected to the spine. But here, between APIC and the leaf switches, APIC must be connecting to the fabric port, which is reserved 4 ports which comes with the APIC based on your order fiber and fiber and copper ports. On the leaf switches, there is no specific, no reserve port for the APIC. You can connect any random 10 gig ports, and you do not need any kind of configuration on the leaf switches in order to activate your Cisco APIC controllers. Absolutely zero configuration required on the leaf switches to connect the APIC. You purchase the hardware Cisco APIC, purchase the leaf switches. You just connect the leaf switches with the APIC, and it will start working. Make sure that you must have an ACI image installed on leaf switches. It has to be in the leaf mode role, and it has to be in ACI mode. Okay, because the role also matter in the new hardware when you purchase. Because any hardware, because this is a very good questions. Any hardware in recent past, when you purchase any hardware which has a 40 or 100 gig ports. When I say the 40 to 100 gig ports, any hardware when you purchase that, you need a 100 gig switch or 40 gig switches. By default, these switches come with the spine role. Spine role. So if you are connecting APIC on these switches by default, nothing will work. APIC will not be able to even start. It will show the wiring issue for you. But when you purchase the hardware, you have to console the switches. Then you have to check that first, whether APIC, the spine or these hardwares are in a leaf mode, leaf role, or the spine role. Okay, and this is very because nowadays the old hardware, which was 10 gig, 100, 20 gig or 25 gig port supports. Nowadays in production, people keep ordering the hardware which are having all the interfaces 40 gig to 100 gig because of the server requirement. If you are ordering that kind of switches, then you make sure that you need to go to data center, console the switches, check the hardware, the leaf mode, what exactly going on. Cisco always suggests that if you're purchasing that kind of hardware. But if you're purchasing the 9300 with the 1 to 25 gig ports, those switches will be always in a leaf role. They will never come with the spine role, because the spine switch required at least minimum 40 to 100 gig interface. If any switches which even if you try to convert these leaf switches into the spine role, they will they give you the error due to the predefined script is configured on the ACI image for the role. Okay. All right. So any doubt till here before I move forward? The architecture wise, this is just a simple plug and play setup I'm showing you. Now between the leaf and spine switches, between the leaf and spine switches, what we run? We have a underlay. Underlay what it runs? IS, MCAST, multicast. Okay. Then you have an overlay. In overlay, it runs the VXLAN. Okay. Then in the control plane with the underlay, it runs the MP BGP EVPN. Okay. These are the protocols which runs by default between the leaf and spine switches. Do we need to configure anything? Answer is no. The moment you connect leaf and spine switches, underlay IS protocol, just like OSPF, it will automatically start forming the neighborship. Now, how the neighborship will form, let's discuss that. Okay, so when you first time logging the API using the CIMC interface, you need to have a certain information with you. Okay, CIMC interface can be done two ways. You can connect the CIMC port to the laptop, and you can configure your laptop as a DHCP server. And you assign the IP address on the CIMC interface, then you try to log in remotely. Second option is, if you do not have that kind of DHCP feature enabled on a laptop, you need to bring your monitor keyboard. Connect your VGA cable to the monitor. Okay. Connect your keyboard monitor or keyboard or mouse over here in the USB, and you can configure the CIMC IP address. Okay, the second option. Now, once you're done with the CIMC, because I do not have physical lab to show this CIMC option. I had to have production one, don't want to log in for that. Yeah. So once you're done with the CIMC access, what you do here is this is the first page. When you log in through the your monitor, keyboard monitor, this is how a page will come. Then you will press the F2 button on your keyboard, and it will give you the details for the your CIMC. It will ask for what is the IP address of CIMC. Do you want to change any VLAN, anything like you need to configure the password for CIMC, everything you have to do it. Okay, once it is done, you can simply say that F10. It means save the configuration of the CIMC after this configuration password and the CIMC IP address. Once you've done that, you will just HTTPS the CIMC IP address. Make sure that you have the reachability. This is how it will page come up. Nowadays is different page. This is the 1.0 version. Nowadays is a bit better page day. You have a currently running 4.x CIMC version. This is a BIOS version. Okay, CIMC version. Cisco by default nowadays are giving the 4. something version with the APIC. Okay. By default, password is password, but you can reset in the CLI also if you don't want to follow the same password method. Once you're done with the CIMC access of the server, okay, what you have to do here is in the CIMC you configure the host name, time zone, and all these things. It's a server management. Once you're done with the CIMC interface, you have an option to call the launch the KVM. Virtual KVM, not the KVM, virtual KVM. KVM is a keyboard video monitoring. Physical KVM is for the CIMC. Virtual KVM is to access the BIOS command line of the CIMC server. Command line of the server, because on the server, by default, you have a CIMC image. CIMC is what? BIOS image based on the Linux. Okay. So once you have that, then on top of this, you have the third app, which is we call that APIC. Okay, which we call that APIC. If you want to access, suppose for example, you are spinning up one VM. How do we spin up VM? We access the vCenter or the 𝗀𝗂𝗃 client, and we spin up the one VM. Then you access that VM via the CIM, your vCenter or vSphere agent, and you configure the basic IP address and everything. Then you remotely access it, right? See, exact same way. Here is your APIC image. When you purchase the Cisco hardware, Cisco by default provide you the APIC image. That's a 90% of the chance you will get that. If you do not have the APIC image, then you have to download the APIC image and reboot your KVM, reboot your hardware with the APIC image. Or we call that re-imaging the APIC. Okay. Once you launch the KVM, if the APIC is installed, if you see that, if you see here, this is the, when you launch the KVM, you will get the chassis, then summary, then you will get that what hardware you have. Okay, what is the firmware version of the CIMC, what is the health of the overall of the device, CPU memory, and you will launch the KVM. Once you launch the KVM, if your APIC image is installed on your hardware, then your APIC, then your image, sometime you will have this kind of interface. This is old version. The newer version of KVM is this one. Okay, you have a right side in the corner. But if you have old version of the CIMC, then this is the version of, you get login the CIMC interface, you get the server summary, then you have a KVM console and launch it. Once you launch it, you will get this page. If APIC is installed on your hardware, APIC image is installed on hardware, you will get this page on the CLI. It will say that press any key to continue. The moment you will press any key, this information it will ask. It will show that what exactly it is for. Now, APIC, since APIC is a GTP server, GTP server is zero touch provisioning server. So APIC is the one which is responsible to do all the tasks on the leaf and spine switches while the integration. This is the day zero task. So in the APIC, what we're gonna do here is we will need to tell the APIC, if you are controlling any devices, then I am going to give you the certain parameters. Using that parameters, assign that value to all the devices. So APIC is the one which is going to be responsible to assigning all the IP address between the leaf and spine switches. No, only between the leaf and spine, nothing else. Okay. All the ISIS configuration, what should be the IP address, loopback address, what should be the the VXLAN tap address, what should be the mpbgp router ID. Each and every task will be done by APIC in a GTP manner, zero touch provisioning manner. Now, when you configure the APIC asks that how many. APIC asks that the fabric name. It means what is my data center name. Okay. The moment you will say that data center is DC1, for example, or for example in the location name, then APIC will say that wherever it is communicating, this is your DC1, the APIC or ACI cluster. Okay. Then APIC will ask, what is the tap pool? Tap pool is for what? Tap pool is for between the leaf. So using this value, tap pool, your APIC will be responsible to assign all the IP address between the leaf and switches and APIC. You do not have any control to do any kind of re-IP or IP customization option. Okay, you suppose you say that 10 dot, this is the default value, I'm saying that 0.0.0/16. So APIC will say that, okay, I have this pool. I have this pool. Usually how you determine the pools, the number of the switches, based on that you determine the pools. If you're having a 10 leaf and spine switches, accordingly you assign the /22 pool. If you have a more than a 10 leaf and spine switches, best practice is to assign the /19 pool or /17 pool. If you have the more than 100 leaf and spine switches, then it is always suggested to have a /16 or /19 pool in your hardware. The moment you will say that this is your RAM pool, APIC will say that, okay, I am going to create the 4 to 5 DSCP server pools.
So
From
tab pool is nothing but the DHCP server pool, right? Or
sorry,
tab pool is nothing but DHCP server range pool, right?
exactly, yeah. Tab pool is nothing, just it is the, so tab pool is the whole range of the IP which we have. So we are telling that APIC, you assign any IP in my environment between leaf and spine for any purpose, that IP must be fall under this range only. Okay, this IP is non-routable towards the external. So if you are connecting any devices to the leaf and spine switches will never advertise this pool IP address to the external network. So why? To avoid any kind of conflict in your environment. Suppose if you have a 2 data center, okay, so you can assign 2 pools separate. One with the 10.0.0.0, one you can assign to 172.0.16.0.0/16, something like that, right? You can assign that way. By default, APIC also you can assign the 8 if you're having more than 500 leaf and spine switches, right? You can assign the /8 value also, because you need a bigger pool. Now, pool calculation, how you assign the pool calculation? There is a method. So if you see that, I had one Excel sheet I created for the pool method creation. Just give me a second. Huh? Yeah, here we go. Have pool calculation. So suppose I have a 3 APIC node. Okay, I have how many leaf switches? 10 leaf switches. How many spine? Just I will say 2. Okay. The number of the ports in the leaf switches, 48 port switch. Number of the VPC between the leaf switches. Since I have a 10 leaf switches, I will say that just 5, because 10 divided by 2 is 5 APIC VPC pair switches. Now, pool size /32 will be always. So if you see that here, the pool, the total number of the IP required, saying that if you put this number, the number of the IP will be required this much. Look here, 384 IP address required for this much configuration. Okay, so then what slash value you can, which will provide this much range? Then accordingly you have to slash, for example, /22 in this case. This kind of excuse me, this kind of calculation always matters when you have bigger infrastructure, right? Or there might be the how to calculate APIC tab pool IP, because there is many method people have sizing requirement. Okay, here we go. I think this is the command line where you can, not this one. People suggest nothing over here. Anyways, No, I think that is the calculation which is fine. I mean, if you see that here, that's fine. Because this is only for the leaf and spine switches. If suppose if I say that 5 APIC node I have, okay, and I have 100 leaf switches. I have a four leaf spine switches, 48 port switch I have. That's fine. All the four, and the BPC I need just like I need just 20. I need 80 switches which will be pair with the BPC. So 20. So total IP address requirement 6,000. The 6,000 IP where you can get is a /16. You cannot get less than /16. Okay, so accordingly you have to say that what exactly you want. Okay, the total going to be, look here, the total number of the pools, 37 pool APIC will create it. So as I said, the moment you give this range, APIC will create the minimum 4 to 6 DSCP pools, and each DSCP pools will have a different role. For some APIC, some pools will say that DSCP1, this will be responsible. For example, it has 100 IP address or 200 IP address or 50 IP address. It will say that assign for loopback. If any device asks you the loopback address from APIC, APIC will use this DSCP pool to assign the loopback address. Second is for the, if you're configuring any BPC in your between the leaf switches, if you're configuring the BPC, then you need to have a pool address which will assign the virtual IP address of the BPC, right? Like how we configure secondary IP address and PIP, right? Here we have to do the same thing. Here we say that DSCP3, it will assign the PTAP. It means all the physical interface IP address between the leaf and spines will be assigned by this pool. So as I said, each pool will have a different role. We will discuss that in a I will show you this in a CLI also, how the APIC will looks like with the DSAP. Once you done this one, then APIC will ask certain more parameters. What will ask in the parameters? APIC will say that how many controllers you have and what is my controller ID. Okay, how many controllers you have and what is my controller ID. So if you'll see that by default, it is saying that 3 minimum requirement. So this is the standalone just by 1. You can, if you have a 3 APIC node, then you have to select the 3. If you do not select 3, by default it will select the 3. But if you have 5, it has to be must be 5 over here. If you have 7, it has to be 7. If you have 9, if you have 9, 9 is not supported, but 7 is fine. 7 till 7 you can update it over here. Why this is required? The reason is the moment you will tell the APIC you have a 3 nodes. You have a 3 nodes. Then APIC will start discovering the other nodes. Via which interface? Fabric interface. APIC will start the discovery of other nodes where they are sitting. Okay, and then it will synchronize the database across the APIC. Database here. So all the 3 APIC will maintain the exact same replication of the configuration, exact same configuration of the database. The moment they will form the cluster, so cluster they are not forming for the network point of view. They are forming the database cluster, DB cluster. So they will maintain the global replica of the configuration. They will exchange the configuration replica to distribute the load among the 3 APIC nodes. Okay, so if you see that here, then what other information? What is the APIC number you have? This is very important. So if you say that I have a total 3 APIC, but when you start with any one APIC, always give the APIC number 1. You cannot log in any APIC and say that this is the APIC number 2, APIC number 3. The moment you will say that APIC number 2, APIC number 3, APIC will behave differently. Okay, then you have to give the host name of the APIC. This can be anything. This is the tab pool. If you see that, What is the infra VLAN ID? This is very important. So when APIC want to communicate with any leaf and spine switches, APIC will create one SVI. One SVI, we call that infra VLAN. Infra VLAN ID. Except the 4, you can give any number. By default, something is selected here. But this ID you cannot use in your network when you're using in the ACI. You have to make sure that you should not be using this ID into the network. If you use this IP into the network VLAN ID, you will have a conflicting. Okay, so APIC will say that if I want to push any configuration or we want to have a health checkup between the leaf and the spine switches, APIC will communicate to its agent. Infra VLAN is nothing, just an agent available on the leaf and spine switches. And this VLAN will have also IP address from this pool. So APIC will, so from this pool, the very first 3 IP, 1, 2, 3, from this pool will be reserved for the APIC devices .1, .2, .3. These 3 IP, very first 3 IP will be always reserved for the APIC devices. Then it will, remaining IP address will be used for all the leaf and spine assignment. Okay, then it will ask that the DSCP pool, sorry, the IGMP pool or the multicast pool, keep it default. This is a suggested one. Why it is keep default? Because this is the pool which will be used for the broadcast unknown multicast traffic, bump traffic between the leaf and spine switches. So you do not have to enable any special multicast feature. No. The moment you can do in the initial setup, APIC will say that I have this pool and each leaf and spine switches will be part of this multicast pool. Okay, then you have a out of band management IP address configuration. Then you have a APIC configuration, the password configuration. These are the only basic parameters. There are many more. Okay, these are the basic parameters of when you set up any APIC. The moment you configure this one, so few things is a one-timer. You cannot modify once you've done that. Okay, what are those? Tab pool. If you, for example, you configure wrong tab pool and you bring up your entire hardware and you're trying to change this tab pool, it means you have to wipe out entire data center. You have to remove the configuration, then you have to start from scratch. This one, and that's it. Yeah. These 2 are very important, non-changeable parameters. Remaining, before it was there like you cannot change, but over the time period, they have allowed to change few parameters. Okay, but these 2 parameters, you should never change it. And it will, if it change, then entire ACI setup will doing the re-IPing. And you will lose the entire configuration of the devices. Okay, this is the always one-time configuration. Once you're done with that information, it will show that this is the GTP detail. It means using these details, APIC will try to make the communication with all the leaf and spine switches. Now, one thing you have to make sure that if this is the APIC 1, this is the APIC 1. This is APIC 1. This configuration only you will do on the APIC 1, especially the password part. On the leaf, spine, and other APIC, password will be same or replicated. So it's not like you change one password to one leaf and spine and APIC. No. Once you configure the password from APIC, since this is the GTP, Zero Trust Provisioning, this configuration will be replicated to all the devices participating in the fabric. Okay, when I say the fabric, one APIC cluster, whoever or whatever devices are managed by the one APIC cluster, we call that fabric or one fabric. Okay. The moment you will say, you will log in the CIMC on the APIC 2, and you will say that I am the APIC number 2. So it will ask that give me your detail, tab pool, and the infra VLAN ID and the management IP address. It will not ask the password. It will say that since you have put the APIC 2 number ID, I will ask my APIC 1 to provide me the password and detail. Same for the APIC 3. So only you have to configure the password on the APIC number 1. Not on the leaf, not on the spine, not on the APIC 2 and 3. On the APIC 2 and 3, you have to just configure these 4-5 parameters. Okay. When you configure the APIC, when you try to establish the APIC, this is how you create the seed for initialization. Okay. What should be your fabric name host? Sorry, what should be your fabric name? Fabric name must be same. If your APIC is in same cluster. Okay. Fabric ID also must be same if APIC is in the same cluster. The node ID, sorry, controller cluster. The port ID also same. You can have a different port also. This is very important, the cluster controller ID. Name can be different. Tab pool must be same if they are in the same cluster. Infra VLAN must be same if they are in the same cluster. Username password only on the APIC 1. Remaining you do not require. Okay. You create this seed before going into the production. Then you go for the initialization of the APIC. Okay. So once you configure this setup, APIC create the one GTP pool. Okay, one APIC create the one GTP pool, and how the APIC pages looks like. If you say that here, this is the APIC. Okay. In the APIC, you have a interface going towards the, and look here. These are the internal process parameter within the APIC. In each APIC, any interface going towards the here fabric port. Okay, this we call that fabric port bond 0 dot. What is the infra VLAN ID? Infra VLAN. Okay, infra VLAN ID plus IP address is what? Is the first IP of the tab pool. First IP. Okay, for her, for example, 10.0.0.1/16. This is the IP address, for example. Okay, then you have a DHCP pool where you have an infra VLAN, tab, and password, everything. Then you have a bond 1. Bond 1 is for what? For the out of band address. For the OOB. Management address. And they communicate like this. They have an interconnectivity. Okay. When you first time connect your APIC to the leaf switches, leaf switch, APIC, what it will do here is APIC will have a LLDP enabled by default. So on all the leaf switches and the APIC devices, CDP does not support. And the moment you will try to touch the LLDP anything, discovery will not work. So LLDP by default is enabled, and you should keep that as it is. The moment you will connect between leaf and the APIC device, leaf will send the LLDP message for discovery message. Okay, in the LLDP, if the leaf say that, okay, I am replying to you. I'm replying to you. Then APIC will say that, okay, you know what? you are the part of the ACI infra, APIC before assigning this thing in the LLDP, APIC will check the at least 16 parameters. APIC will check the 16, APIC perform 16 checks. APIC perform the 16 checks between the leaf and spine switches, between leaf and the APIC device. And this performance or this validation checks is done on each and every devices from APIC. So before APIC send the LLDP discovery message to the leaf switches, then it will perform the 16 checks. And what are those 16 checks? APIC will perform the operating system, role, hardware, because not all the hardware support the ACI. Okay, it will perform the BIOS. It will perform the cable, whether your cable is right you are using or not. It will perform the many LLDP services. It will perform the let me check that. I forgot it. APIC checks validation on leaf switches during discovery. So if I say that, I have must be somewhere. Yeah, look here. Yeah, I think in the 6.0 they have added couple of more. So it will check the state system, IP reachability to the APIC, infra VLAN, LLDP adjacency, OS, EPLD, SSL checks. SSL checks is very important because it will APIC will say that okay, whether you are secure to communicate or not. Then APIC will download the policy to the leaf switches. Then timer, module, PSU, fans, and all these things. Okay. Now this is how you check that. I will show you this in the leaf also. So any checks which are serious, for example, if there is any power or module fan failure, your APIC discovery will not be disrupted. If your APIC is pushing some configuration on the leaf switches, bootstrap configuration we call that. Okay, and APIC is saying that what, I'm unable to leaf is saying I'm unable to download the image because the version is incompatible. Then some few parameters is non-compromisable between the leaf and the APIC. Okay, especially the version. Suppose APIC is running the 4.0 version, and here you are running the 16.0 version. APIC will say that there is no compatibility for discovery. If you want to have a compatibility, either downgrade your leaf switch or upgrade my APIC. APIC will not push any new configuration on here. Okay, if there is any LLDP issue, APIC will say that there is a LLDP issue. If there is any IP reachability issue, when I say that, look here, IP reachability means along with the LLDP, APIC will, from DSCP pool, APIC will say that, what, get that some IP address on you, and then try to connect to my APIC virtually. This is dynamically happen. If there is any reachability issue, something happen, then APIC will say that, okay, there is reachability issue. There is application vector. What is the application vector? I will show you this. Okay, so these are the parameters. SSL is always important. If SSL is failing, then APIC will also not be establish the communication. Okay, so this is the very important parameters which APIC does. Okay, the moment LLDP sent to the leaf switches, you see here, make sure that your APIC, when you connect the APIC to the leaf switches, leaf switch must have the spine connectivity. If there is no spine switch connectivity, it's not recommended to even start the discovery process. Okay, in the policy, the moment APIC discover the LLDP to the neighbor device, what it will do here is the moment APIC will say that I've got the IP, okay, sorry, one switch here, send the LLDP, then leaf switch will say that, you know what, I need from you IP address. It will send the DHCP request. So all the DORA process happen. DHCP, discovery, offer, request, acknowledgement. So APIC will get the discovery message, then APIC will say that I have a DHCP pool. I am going to offer you certain IP address. Then leaf switch will say that, okay, based on the offer, I have sent you the request saying that I want this particular IP address from this pool. Then APIC will say the acknowledge. Okay, this all the process happen. Once the APIC and leaf switch will say that I've got the IP address, then APIC and leaf switch will assign the or create the one SSL tunnel between them. SSL tunnel between them for secure communication. After this, APIC will push the policies on the APIC device, on the leaf device. APIC will push the policy on the leaf switches. Then APIC will, leaf switches will say that in the policy, what information it will have? It will have the ISIS configuration, multicast configuration, BGP configuration, VXLAN configuration. Okay. Once the leaf switch will get this all the information, then APIC will say, leaf switch will say that, you know what, I have another switches also which are connecting to me. And what are those switches? Those are the spine switches. And this leaf switch will say that I have another switch here which is connecting to my fabric port. When it will say that, the moment APIC will push the policy, and in the policy you have a certain configuration which will be applied on the fabric port, because the port type itself called the fabric port. Then the leaf switches will say that, okay, I have got the certain DHCP request or LLDP request from on the fabric port, and since the fabric port configuration maintained by the APIC, I will tell this information to the APIC. So in the end of the day, only one leaf switch will get the information with the APIC devices. Then that leaf switch will act as a proxy to entire infrastructure. So whatever topology you have between leaf and spine switches, the moment APIC will say that I have one more spine switch here, then APIC will say that, okay, you know what, I will push the configuration on the spine switch also. Then a spine switch will say that, you know what, I have a few more connectivity with another leaf switches. So a spine switch will again act as a proxy to the APIC device, saying that I have another switches. Please push the policies to that switches also. What policy? DHCP policy, where we'll have all the IP addressing, everything, and policy and the routing between them. Okay. Now, how many IP and how the IP assignment works? We are sure that DHCP is the one which assign the IP address. Okay. But between the leaf and spine switches, spine required a certain different IP addressing. There is no physical interface IP addressing. Okay. Have you guys heard about the unnumbered IP address?
Yes.
So what does it do?
So it is assigning the existing interface IP /31 so that it can be used to all the interface.
Yes. So you do not need IP address on the physical interface. Basically, this is a proxy interface. Okay. So if you have the loopback address in your environment and you have a physical interface, and you're saying that, you know what, I do not need to create the physical IP address on the physical interface. I can use this loopback address and tell my interface, you know what, use this loopback IP address itself. I do not need to give you the interface IP address on the physical interface. Same exact concept happened here. So between the leaf and spine switches, whatever neighbors, whatever things happen, these physical interfaces are not having a physical IP addresses. So they will say that there is a command unnumbered. So APIC will say that I have pushed the loopback address on all the leaf and spine switches. Loopback 0 will be reserved for the P tab. Okay, physical tab. It means physical interface will use unnumbered command to utilize and to make the communication between the leaf and spine switches to form the neighborship. For neighborship, for what? For all the underlay and everything. Each leaf and spine switches will have a different loopback address, and each loopback address will have a different role of it. Spine around get the 10 to 15 loopback addresses. Leaf switches get the 3 to 4 loopback addresses. I will show you this. Okay, from where? From the APIC, from this DHCP pools. As I said, some APIC will have a P tab, some will have VPC, some will have a VXLAN tab, some will have a routing tab, everything. And that is a pre-scripted in a bootstrap configuration. When you APIC discover this leaf switch here and assign the DHCP IP address, APIC will push the bootstrap configuration. And in the bootstrap configuration, you will have all the routing, all the IP addressing, which APIC will automatically prepare for you and push on the leaf and spine switches. Okay. Now, if we talk about what loopback addressing things happen, before that, what type of issue you can face during the discovery? Suppose you're trying to discover an LDP working fine, but in your APIC, you see that the status of the devices are certain different, is not active. If you're having unknown, if you're having undiscovered, if you're having discovering, if you have unsupported, if you have disabled, inactive, active. If active means your devices are fine, health are fine on the APIC. If anything we say the unsupported, it means there is a certain hardware which are not hardware model which are not compatible with your ACI infrastructure or with the APIC. Okay, disabled means status. You will see that this devices is being removed from the APIC fabric, from the APIC managed mode. Okay, see that here, this is the status of the APIC. So here, if you see that the any devices will have a different status, even during the discovery, after discovery, you will have an issue. For example, if you during that LLDP and discovery, you see that this error, fabric domain mismatch, or UUID mismatch, or wiring issues, unknown neighbor, adjacency not detected. These are the major issues I've captured so far during my discovery. Domain mismatch, I have got that. Wiring issue, I did. As I said, invalid connection. If leaf to leaf you're connecting, leaf to non-leaf you're connecting, spine to non-leaf, or the spine to the leaf APIC devices, you will see that wiring mismatch issue in the node itself. If there is any LLDP disabled forcefully on the interface where APIC is connecting, then you say that this issue, adjacency not detected on, and you will have an issue with that. Okay. Now, if I open the APIC, for example, oh, really? If I open the APIC, where did I open it? Just give me a second. If I go here, so I have APIC. So the DHCP pool, each and every configuration is already done on my APIC. Before starting the discovery, I will show you this. Okay. Because this is a virtual lab, so we will not have a CIMC access. I will try to get some CIMC access in future. Okay, so if I open this, If I say the APIC open, so you can create even FQDN. So if you're having a 3 APIC node, okay, 3 APIC node, you can log in any device, any one APIC IP address, and you can do the configuration into it. End of the day, they will replicate everything to each other because if they are in a cluster. Admin, let's see, what is the password? Admin C1SCO12345 C1SCO12345. Okay, so this is the epic I have. So when you first time log in the epic, this is how the page will looks like. Okay, here you will see that start the fabric setup. You will get the option from here, but you do not have to do anything from here. Okay, if you want, you can do it if you already have in detail of it. Here you will get that what new features you're gonna get in a APIC 6.0 version. What are the new hardwares you are going to get over here? Okay, all these things will be there. Basically, it's kind of guideline. Then you will go to you will see that these many tabs over here. You will go to the system tab. In the system tab, you will just simply say that controllers. Show me the controllers. Currently, if you see that just one APIC is showing over here, because this is just one APIC. Cluster is not formed. It means we are into this state. We are into this state. So we have another APIC which are connecting to another switches. Okay, but APIC 1 will not be able to discover another APIC until and unless APIC 1 having all the devices registered into the database. Then these devices will pull all information to the host port and say that there is another APIC. Form the cluster. Okay, you just simply configure the CIMC interface, APIC pool configuration, and connect your APIC 2 and 3 to the leaf switches. And log in the APIC 1 and try to start the discovery and policy push from APIC 1 to all the switches. The moment in all the switches will register into the APIC 1 will automatically detect the APIC 2 and 3, which are connecting to the any APIC, any leaf switches. Okay, we'll see that here. Cluster scene, there is a no cluster for now, but you can see that certain information. What information? You can see that here, what configuration we have here. Let's see. Come on. If I edit and let's give the option no. It is taking time. Let's refresh. So I will show that what infra VLAN we have set up during the setup. Okay. What pool address we have, what fabric name we have. Okay, come on. Here, if you see that here, I will say that cluster. You will see that I was showing the bond 0 and bond 1 interface. Bond 0 interface is connecting to where? To the fabric interface. And bond 1 is connecting to the management interface. In real time, you will see that physical interface detail over here. 4 interface, and out of 4 interface, which interface connecting to the leaf switches. It will show you once I will discover it. Come on. Why it is taking a lot of time? Anyways, I will show this, might be stuck. So once you have this detail, okay, here APIC and everything. Once you have this configuration, go to the fabric tab. In the fabric tab, you will see that how many devices this APIC is detecting. You will see the fabric membership. In the fabric membership, you will see that registered node, how many nodes is being managed by this APIC? Currently 0. How many nodes are pending, you will see that saying that there is a one leaf switch which is being detected by this APIC. I will say that, okay, register this leaf switches, pull the information. I will say the leaf node ID will be 101. Name I can give anything, leaf 101. What is the role? Role I'm going to give that leaf switch only. Rack information you can also pull that, like where it is connecting, what is the detail, everything you can put here, right? But as of now, I'm just saying that register this switch. The moment you will click on the register this switch will say that, okay, I'm going to request the APIC, and APIC will pull all the information. Okay. APIC will put all the information, then status will be changing. How many status type we have? We have many status type over here. Unknown, okay. Then we'll go to the discovery. It means node is discovering, but IP address is be not assigned, but it is assigning that. Then it will go for the eventually active mode, unknown mode. You will see that the node register pending is totally gone. If you go to the registered node here, look here. Status is still unknown, but it is still discovering. But you will see that here, IP address is being assigned over here. And this is the model number of the API, your leaf switch. If I go to the now on the fabric system, I will go to the controller. Let's see if that give you the information. I'm not sure. It's taking a lot of time. Anyways, I will show this. The moment you will discover, add one leaf switch is here. Okay. Currently saying that active. Okay, the status is active currently. If I say that if there is any pending node, look here. What is saying that? There is a two spine switches which are being connected to this leaf switch. So this leaf switch saying that I've got the here information. APIC is saying that I've registered you, but this leaf switch is saying that I have got all the information, IP address, infrared and everything. On the fabric port, I have two more switches which are detecting, which are sending the DHCP and LLDP request to me. So this switch is redirecting traffic to here. Okay, if I log in the APIC and see that discovery message should be coming. If I log in the APIC, just give me a second. If I CLI, not this here. Put T. And APIC, if I say APIC, if I maximize this page, come on, stuck, don't know why. Come on. Oh, entire. All right. It was issue with the page. That's fine. So I will say that 14. Now, if you see that APIC SSH. Oh, really? What happened? Restart. Come on. Why APIC is not accessible? Just give me a second. Let me refresh the page. Put T. Decision. Close the network. Oh, there is something issue with the APIC. Really? I wanted to show you this. I don't want to move forward before I show you this. I wanted to show the logs from CLI. I should be able to access. I don't know why it is not letting me logging the APIC. Okay, anyways. I'm stopping here today, okay? I will be resuming the exact same topic from discovery. Oh, just give me a second. Huh? Probably this could be the reason. I will be resuming the discovery part. Okay, here we go. Sorry, it was Cisco 1, 2, 3, 4, 5. All right, once you log in that, and I will show the dscp logs, how these dscp logs is being seen by these nodes. Okay, if you see that, so controllers, okay, details, not ID. So just controller. It will show that how many APIC node currently it has. If APIC has detected another nodes, it will say that currently APIC has just one node. Okay, and if I say that AV read application vector details, it means show me your pool details. So look here, currently APIC is detecting not second APIC also. But here if you see that APIC 1 is saying that this is the version, this is my IP address, this is my pool. This is my pool and it is the port 1. But APIC 2 is detected, but APIC 2 having just one pool ID and nothing else. Now, if I want to show you this, just give me a second. I want to show you. Not here. Okay. Let me put the command to get that detail. Yeah, here. No, it will not show the LLDP. It's not a physical device. If I show you DSCP, yeah, this one. grab, show me the DSCP process. I will walk through all the process. Don't worry about this. I'm going to go the deep dive of it. This is, I'm asking this APIC, show me the DSCP logs. Okay. So let's see what logs it says. All right. So you will see here. So currently this leaf 1 was sending some message and there was some error. Now if you see that here, all right. So you see that DSCP, okay. Let's say that no more command, okay. If I say that no more command, yeah. So here, if we'll say that here, DSCP, look here, Dura process. It's saying that this device currently is trying to send a discovery message. What is the tap IP? What is the serial number of the device? 104103. And this is the MAC address of the device. DSCP discovery message is trying to send. But currently, I'm not sending any offer. I'm not sending any offer. The reason I'm not sending any offer because I have not tried to register that or validate that device. So these two switches are still sending the DSCP message to where? To the leaf 1, and leaf 1 is sending to the APIC device, and APIC device is saying that I'm not currently validating any this DSCP. I'm not assigning any IP address. The moment I will say that I assign the IP address, I will say that, okay, I'm going to validate 201. This is the spine 1. I will say registered. The moment I will say registered, it means I'm telling here assign the DSC, offer the DSCP and assign the IP address. Here. Okay, if I show you this DSCP services, where exactly? I should see the offer and everything. Let me show that. Yeah, more. All right, so you see the DSCP offer, error. So let me say that. I will say that, not here. I can get the exact the DSCP traffic only rather than this request. So I will say that show me only grab DSCP offer logs, no logs, DSCP. Yeah, so DSCP discovery I'm receiving. I should see that offer, acknowledgement, everything. Now I'm getting another switch, this one, and keep sending me the DSCP request. Let's see, DSCP offer, DSCP discovery message. Where is the offer and acknowledgement? Come on. So saying that this is the leaf switch, okay? This has a fixed IP addressing, okay? This is a node ID, and from here, I'm trying to, this is the bond 0 from, okay, here we go. So from bond 0, we are offering this IP address to this leaf switch. This is the MAC address of the leaf switch. From where? From bond 0 interface of the leaf switch, sorry, APIC device. And APIC device is receiving the APIC device is not our server ID. Okay, APIC device is receiving the DSCP again communication. Also, this is the discovery. This is the offer. This is the request. This is the acknowledgement between the leaf and spine switches. Between the sorry, APIC and the leaf switch here. Okay. And this was for this one tab. Same exact process will happen for all the devices. Once the IP address is assigned, then APIC will push all the policy and validation or the bootstrap configuration. Okay, APIC will push all sort of configuration on the devices. Yeah. Any confuser till here? Just for discovery, nothing else. Okay, I will be going more deep into the discovery process. I'm just giving you the just overview of the discovery, how the DSCP discovery works and get the IP address. You're gonna get a lot more stuff over here. Okay, if you want to check the DSCP, logs, that's different thing. If I want to check the DSCP pools, I mean, a lot of configuration, a lot of things you can do here. For example, if you want to check the DSCP pool, what pool we have, right? How many IP addresses been assigned? You can get it from here. If I, for example, here, I will say that rather than DSCP pin, DSCP pool. Not here. What was the spelling? DSCP pool .bin.log DSCP pool .bin.log file. Now, just give me a second. I have the command which should show yeah, this is the one I'm query. DSCP pool. Show me the entire DSCP pool which you have. Okay, so come on. I will say the memo query -c memo query. Come on. Demo query. It's a bit slow. I don't know why. Demo query. No. Do one thing. Let me do it in next session. Okay. It's a bit slow. I don't know why. Just frustrating. Yeah. Bash demo query -c dscp pool. Look here. How many pool it has created? Oh, really? Okay, here. So if you see here, this is the just non-production environment. Okay, I have a DSCP pool 1. So you will see that from this range, from this tab pool, what is the range we have? This is the starting IP address. This is the ending IP address in the pool 1. In the pool 2, from this one, this is the starting, this is the ending. If you see that each IP address is different from this range. From pool 2, 3, and it has different role of it. This is the 𝗲 IP address. If any leaf and switch will try to get the 𝗲 IP address, it will get the from this range, pool 3. In production environment, you will have a many more. Okay, many more DSCP pool IP addressing, which I will be exploring in the next session. Okay, I will be showing all the details low level in discovery. Okay, any question, anything you guys have? If not, then thanks for attending. And I will be resuming on 22nd of October because I'm traveling to India. And wishing you all happy Diwali. Enjoy. Will connect you on 22nd of then, right?
Okay, sir. Happy Diwali, sir.
Cool. Thank you,
Thank you,
guys.
Dinesh. Happy Diwali.
Yep.